So as we just talked about, an algorithm is really just a series of directions that we're going to use to solve a problem. The step-by-step directions in order to solve a problem. So what we want to try to do is maybe play first with developing an algorithm. Could you come up with the strategy to solve a problem? And our problem we want to play with today is going to involve a deck of cards. If you have a deck of cards, feel free to go get them, and you can take them out and shuffle them up and then deal yourself 7 or 8 cards face down on the table. If you don't have a deck of cards, you can easily just get a couple of pieces of paper, and then on one side of the paper, write out some random numbers, that would be in a deck of cards: ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king. You can just write out a series of numbers and then put them value face down, right? So if you wrote out a 10, you can just take it and put it on the table face down, okay? So feel free to pause the video if you need to, and you can get a series of cards to be able to work with. Okay, so our algorithm here, and the problem we have to solve is, I need to be able to find the smallest card in this deck, or in the hand you've been dealt. I need to find the smallest card, all right? So that's the problem we have to solve. Now, I bet that some of you would say to me, yeah, Mr. P, I'll just put out some other cards here. Why don't we just turn all the cards over and look at them, right? If we turn all the cards over and look at them, I can easily tell that, let's say the ace is high, the 2 is the smallest. I win, right? But your computer can't do this. Your computer just can't say, look at all the cards and tell me which one is right. It needs a little bit more of a methodical approach to be able to do that. Okay, so that's our goal here today, is to try to figure out what is the smallest card. All right, here are some of the rules. And the rules you will also find on the handout I'm going to put on Classroom with this video. Number 1, if you are, all the cards have to stay face down on the table. If it's on the table, it has to be face down. You cannot put a card down on the table and have it facing up at you, right? If it goes down on the table, it has to go face down. Number 2, you can pick up cards if you want. You could pick up cards, but you're only allowed to have 2 cards up at the same time, one in the left hand and one in the right hand, okay? So if I were to pick up 2 cards, I could hold one in the left and one in the right, okay? But if you want to put any of the cards down, you have to put them down face down, okay? You can, when you have the cards face up in your hands, you are allowed to look and compare the values of the cards you're holding to determine which one might be greater, okay? So we're looking for the smallest card here. So if you wanted to, you could pick up 2 cards and now compare them. The only cards you're allowed to compare are the ones you're looking at. I don't know the values of these cards. So you're allowed to compare which one is smaller, okay? Which one is smaller. But the 9 is the smaller card here. If you want to put one of the cards down, if I put down the jack, okay, you really no longer know the value of this card. The only way you can be sure that you know the value of the card is when you're looking at it, okay? So you cannot memorize the values of cards when you put them down. As far as you know, this card is now unknown, okay? And when you do pick up a card and now you know the card's value, you cannot memorize its position. Right? You're not allowed to say, the 9 is there. And let's say you got all the way to the end and the 9 was the smallest card. Oh, I remember I put the 9 back here. No. The only way you know for certain what a card is when you're looking at it. If you're looking at it up top. Okay, if you're looking at it face up. Okay? So, there has to be a clear end to your algorithm, right? You have to be able to get to a point where you know, I found it, and I know which card is the smallest, okay? We have to think of this algorithm in such a way that it could work for any size deck of cards. I could deal you out 8 cards, I could deal you out 500 cards, and the general strategy would work no matter what, okay? So, On the handout I'm going to post on Classroom, I'd like you to try to take a stab at it. What do you think you can find? And I want you to kind of write out the directions in English, right? How would you explain it to someone? Okay, we're eventually going to want to turn this algorithm into, if we were doing some coding, we could use this algorithm as kind of like a game plan for us to now develop code. We're not up to coding yet, but in this case, we're just going to be able to develop the plan, and you can write this plan in English. Okay, the fancy computer term we'll use for this is called pseudocode. It's not quite code, but it's logical English statements that could be able to figure out how to solve the problem. Okay, so that's your task. Again, if you have a deck of cards, go get yourself a deck of cards and deal yourself 8, and actually let's play with this. If you don't, you can kind of write your own cards on a piece of paper, no problem. Okay, so I'd like you to try this and see, can you come up with your best guess as to what an algorithm could look like in order to find the smallest card.